Welcome to the video, Introduction to the Moon, the Earth's nearest neighbor. The Moon is our nearest celestial neighbor and Earth's only natural satellite. In this video, we'll explore the Moon's basic physical properties, its motion around Earth, and how those motions create the familiar lunar phases. We'll also look at surface features and why the Moon has such an important role in Earth's tides and long-term stability. The Moon orbits the Earth in about 27.3 days, following a slightly elliptical path. Because the Moon rotates once on its axis in the same time it orbits Earth, we always see the same hemisphere, a phenomenon called tidal locking. This synchronous rotation is common for moons in our solar system and is a direct result of gravitational interactions. The Moon's phases are created by how sunlight falls on its surface as it orbits Earth. We see different fractions of its illuminated half depending on the angle between the Sun, Earth, and Moon. The familiar cycle, new moon to full moon and back, takes about 29.5 days. That's slightly longer than the orbital period because Earth is moving around the Sun at the same time. The Moon's surface shows two major landforms, the darker, smoother seas formed from ancient lava flows, and the brighter, heavily cratered highlands. Countless impact craters cover both regions. Since the Moon lacks wind, water, or plate tectonics, its surface has barely changed for billions of years. When you look at the Moon, you are seeing some of the oldest intact landscapes in the solar system. The idea of a dark side of the Moon is a misconception. The far side receives just as much sunlight as the near side. We don't see it from Earth because of synchronous rotation. The Moon turns at the exact rate needed to keep one hemisphere pointed toward us. Spacecraft only revealed the far side in the mid-1900s. Compared to the near side, the far side's terrain is rugged, with a multitude of impact craters and relatively few flat and dark lunar seas. Eclipses occur when the Sun, Earth, and Moon line up precisely. A solar eclipse occurs when the Moon blocks sunlight from reaching part of Earth. A lunar eclipse happens when Earth blocks sunlight from reaching the Moon. These alignments don't occur every month because the Moon's orbit is tilted about 5 degrees relative to Earth's orbit around the Sun. The Moon's gravity pulls on Earth's oceans, creating the familiar pattern of 2 high tides and 2 low tides each day. The Sun also contributes, so tides are strongest when the Moon and Sun line up during new and full moons. This ongoing gravitational interaction also slowly pushes the Moon farther away from Earth, at a rate of about 3 to 4 centimeters per year. The Moon stabilized Earth's axial tilt, which keeps our seasons relatively consistent over long periods. Without the Moon, Earth's tilt could vary wildly, producing extreme climate swings. The Moon also preserves evidence from the early solar system, making it a scientific time capsule. Studying it helps us understand how planets and moons formed. In this introduction, we explored the Moon's physical characteristics, its orbit, the phases, and why its surface looks the way it does. The Moon is not just a bright object in the night sky. It's a natural laboratory for physics and a key part of Earth's long-term stability. Thank you for watching.